Vegetable food loss is a problem. More than half of them are vegetables from farmers and supermarkets, and most of them are still eatable. Therefore, I focused on a new material called cellulose nanofibers. We can create a circular economy by buying vegetables from farmers and supermarkets and turning them into cellulose nanofibers to create a new product. My target is waste vegetables at supermarkets and farmers. Using the power of science, we transform waste vegetables into various materials and products to create a circular economy. WWF and Tesco published Driven to Waste. These new estimates show that about 40% of all cultivated foods are eatable. This is higher than the previously estimated 33% figure. Combined with the latest data on supply chain losses and retail and consumption waste, food loss and waste from farmers has become an issue. Agricultural waste includes animal waste, food manufacturing waste, crop waste. In addition, non-standard vegetables and vegetables that have been affected by the climate have also been disposed of. Cellulose nanofibers are made from wood-derived fibers that have been defibered to the nano-level of a few hundreds of microns or less, and are the most advanced biomass materials in the world. Since the material is derived from plant fiber, it has less environmental impact in manufacturing and disposal. The Nippon Paper Group has a large cellulose nanofiber factory and sells various products. These are examples of products using cellulose nanofiber, such as flexible OLED and 100% biomass plastic bottle. Biomass plastic have their own challenges in expanding applications and social implementations. The biodegradable biomass plastic PBS and PHPH can be expanded in strength and rigidity by cellulose nanofiber. Cellulose nanofibers, including chemically modified products, have been shown to biodegradable in soil and the ocean. Despite growing call for plastic reductions, the volume of plastic packaging from UK supermarkets reached a record high in 2019. That is, plastic flow into rivers and oceans. Our natural environment is further polluted with plastic, and plastic are also in the food chain. Therefore, if we use the packaging using biomass plastic that is biodegradable and recyclable from the vegetable left in the supermarket, we don't have to throw away the vegetables and destroy the environment with plastic. Therefore, I decided to design a machine to make the raw materials for cellulose nanofibers. Carrying vegetables as they are is bulky and costly. Therefore, I thought of a machine that could extract the raw materials for cellulose nanofibers and then transport them to the factory. I developed my idea. When vegetables are placed in the machine, they are crushed and strained to produce raw material for cellulose nanofibers and vegetable drugs. Vegetable drugs are used as compost by farmers. This is a mechanism inside the machine, and these two direct crush vegetables. This is the image of the machine. And this is the concept of the system. The vegetable left over at supermarkets and farmers are crushed with the same machine. Then, the company buys the resulting materials and transport it to the factory to make a new product. The main products are OLED and plastic substitute. And here are the storyboards from the perspective of farmers and supermarkets, and the storyboards from the perspective of companies. In order to collect materials efficiently, companies, farmers, and supermarkets are connected by an application, And farmers and supermarkets enter the amount of material obtained each time. And when a certain amount of accumulated, the company goes to collect the cellulose nanofiber. I designed supply chain management system. Since the amount of surplus vegetables changes from day to day, make a basic estimate based on the amount of cellulose nanofiber obtained, and then determine the final price by comparing it with the factory inventory. Each of these processes runs on the basis of computer data. Thank you for listening.